Hello there, welcome to Blockchain Nuts and Bolts. This video is all about IPFS, and that basically comes out as InterPlanetary File System, and wherein IPFS, as we move and know IPFS further, we'll come to know that IPFS is going to be one of the best friends of blockchain, and how and why, of course, we'll come to know as we move ahead. So this is an approximate understanding. IPFS, the technology here, what I'm going to discuss in this video is an approximate understanding because it's a complete ecosystem in itself. So it is not just about one software that you download and you can start using it. Absolutely, yes, of course, that's the case, that you'll be able to download and you'll be able to use it. But the backend mechanics, it's huge. So here in this video, I'll be giving out an approximate understanding of how the things are basically working behind the scenes. So first of all, what IPFS, how did it come in the being, is it was created by John Bennett, and who later founded Protocol Labs also, and this was done way back in about May 2014. So that was the first time some mention of IPFS came onto the web. So this IPFS video playlist, this has got two parts, part 1 and part 2. So this part is part 1, what I'm speaking right now in. So this will be primarily constituting of only the theoretical aspects, just a brief glimpse to know what exactly the technology is working like behind. And then the part 2 will be part 2 or maybe part 3 also. That will be primarily focusing on the hands-on part of how exactly the commands are given, of how exactly the files are built upon, distributed in nature. So IPFS is all about storage. So that's the first time that I'm mentioning. Yes, IPFS is all about storage, distributed storage. So what exactly it is? So IPFS is essentially a file system that allows you to store files and track versions over time. So it is much like the GIT that keeps track of them on a distributed network. Maybe something that you can be synonymous with is like BitTorrent. And this storage system, that IPFS, it allows direct interaction through a secure and global P2P network. So by combining these secure and global P2P network, these two properties, IPFS enables a permanent next new generation web, and it augments the way we use existing internet protocols like HTTP. So basically it is augmenting, or maybe it is kind of substituting, giving an option that there is a way to access websites other than HTTP, the widely known HTTP or the traditional method. Then the third is IPFS allows users to share files and information without barriers. There is absolutely no barriers, there are no geographic boundaries. IPFS basically works well with large files that can consume or require high bandwidth to upload and download over the internet. So all this theory part, of course, we'll associate each and everything with the practicals in the second part, but these are bare essentials that one should know when we speak about IPFS. So the core idea that the developers built IPFS with is to model all the data as part of the Merkle DAG itself. So what Merkle DAG is itself, we'll touch upon. In a distributed network like IPFS here, when an object is loaded onto the network, anyone who has access to the file's hash address can access its content. Now what exactly does it mean is, we'll understand it later with the practical part, but any file, suppose you have a file and you want to upload it to IPFS, so the only thing which will be required by the end user will be IPFS hash. So that again, we'll discuss what are IPFS hashes. And the last thing that I'll just mention about here in these characteristics are that blockchain is a decentralized data management platform, of course, and that provides immutability. Therefore, it is a good choice to support file traceability metadata on a distributed file system like IPFS here. So in all, we can say that thanks to the great similarity between the IPFS and blockchain, they are going to be huge friends. So as I had also discussed earlier, that blockchain is not meant for storage. Blockchain has got its own peculiar characteristics of providing you immutability, transparency characteristics, privacy, security, etc. But the thing is not about storage. So whenever we speak about blockchain, we are trying to imbibe all the characteristics of a blockchain, but we cannot use it for storage, big file storage. Of course, for small transaction hashes, we can use it when Bitcoin blockchain is one of the leading examples. But when we speak about application domains, healthcare or smart buildings, smart cities, etc., we need to have a way out wherein we can handle all that data. Now, when we are speaking about decentralization, it doesn't mean that we only are confined to decentralization for the blockchain part. No. Whenever anything gets associated with blockchain, like for example, we are discussing IPFS here, so that also has to be decentralized, the storage part. So how do we ensure that decentralization part for storage? IPFS is one way. So IPFS provides the distributed, authenticated and hash linked data structures. So all these parts, distributed, authenticated, hash linked, we'll discuss ahead, but these are the basic 3 parts that I'll just mention out here, and these are very important to remember: distributed, authenticated, and hash linked. So distributed system for storing and accessing files, websites, applications, and data. Anything that can exist on the web. It can be any kind of data. It can be a website, it can be an application, it can be a software, it can be a PDF, it can be a document, it can be a video file, it can be a music file, anything, any data that IPFS can be used there. So for example, just to give you an example, so let's say that you are doing some research on artworks. So artworks, you might start by visiting, you're bound to get this page, Wikipedia page, wherein you will be able to read that what artworks are all about. So this is the typical thing that we see here, the typical website example. So in case we have this HTTPS protocol being used to access information about artworks, so it will look something like this, what you see on the screen. So this website address, this wikipedia.org.wiki artwork, this follow the template, this follow the format of a URL, of a typical URL that you see on the screen here. So this is a typical thing that HTTP, then you have got your URL wikipedia.com, and then you can just place around here what's going to be the path. So this is a typical URL that you have to use while you want to access any kind of content on the web. So when you put that URL in your browser's address, what happens is that your computer, your device, it asks one of the Wikipedia's computers across the globe to get permission to access that information on the page. However, while over last few decades we have been only purview to the HTTPS mode, there is another way which has come up with in the form of IPFS. So IPFS, in case we want to share, if we want to access the information of artworks on Wikipedia, but not on HTTPS, there is another way, that is IPFS. So IPFS, if you ask, so the address of an IPFS protocol which will give you the same information will look something like this. So let's check out both the pages. So both the pages will exactly look the same. So we'll go here and we see this is n.wikipedia.org, and we get all this information about artwork. This is the typical Wikipedia page, but the same can also be accessed in case we just copy this link, again open in another tab, the same address, and this is the IPFS way. So exactly the same page has opened, so same information, but we are accessing with this is the IPFS way, and this is the typical Wikipedia page. So now let's get back to the presentation. So here, how do we identify and retrieve data in a traditional setup? So again, I'll come back to the URL format. So this is the typical format wherein we have a protocol, we have a prefix, we have a domain name, we have a host name, we have got the path to the content, file name, and extensions. So this is any web page that you want to access, you have to have this kind of address, and then you will be able to put it in a browser and you will be able to access your content. But in a IPFS, things are a little different. So things are stored and hosted differently here in IPFS. So let's understand. So to understand IPFS distributed storage, what we need to get clarity on is what's the difference between a location addressing and a content addressing. So let's understand the location addressing first. So what location addressing is all about? So location addressing is all enabled on a centralized web, and it relies on trustworthy authorities to host data and user location based URLs for access. So this is the typical URL that I have already explained in the earlier slides: protocol, domain name, path, etc. So this is the HTTPS way of accessing. Now what's the problem here? The problem is that location addressing will look forward to a location. It will be moving towards a location, identifying a location, whether it is a folder, whether it is a drive, whether it is HTTPS. So identify the file where it is located. If it is a website, suppose, so the website, the moment we press enter to look for that particular website, it goes to that particular server and it accesses that page. So it is trying to identify the location. So but location addressing, there is a problem. What problem? So suppose, this is one example that I have taken on 10th February 2021 at 6 o'clock. This is the website https://anupam.com 1.png. There is absolutely no website till now, but this I have taken for example. So there can be a website which is anupam.com/1.png, and on 10th February 21 at 6 p.m. this is showing something like this. So this figure is there, but exactly on 10th February 21, after about 1 hour at 7 o'clock, this path remains the same. the URL address remains the same, but the figure is changed. So that is a difference that you will be able to identify the problem and the threat. What has been happening in past hacks, things you have read about hacking, the web pages are attacked, and when web pages are attacked, this is what happens: the substitution takes place. So in case there is one.png identifying some other information, the same one.png will be able to identify some other information on the same address. So URL remains the same, but the content is different. So this has been a traditional threat, and this is a peculiar problem. But what happens in IPFS, which basically is enabled on content addressing? So content addressing is, instead of being location based, IPFS addresses a file by what's in it. And when we say what's in it, it means the content. How? So example, I'll just take an example over here. So we have this input, we have got a figure, we have got a photograph. Then this is the IPFS way that I am telling you, and this gets converted into the binary equivalent, 1 zeros and lots of zeros 1. This is just an approximate schematic way, otherwise this is not the exact equivalent. So this is just a schematic to explain. So this complete binary thing that has been converted from the figure, this gets divided into a number of chunks. Now chunks are basically divisions of the same data, but they have been divided equally, and that division, I'll again give you an example to show it. So after that main chunk is, after that main binary is divided into chunks, it takes the digests. Now digests are again hashes. So we take hashes of all these chunks. Now I am going to show you also a simulated way on a website, dag.ipfs.io. I just way ahead. So now what has happened till now is we have got a input. We have got an input here, and we have got taken the binary equivalent here, and this complete thing, what you see on the screen, sorry I do not have a fluent way of marking the things, but you will be able to appreciate that the things that I'm highlighting here is the chunk. So that same binary file has been converted into chunks. That chunks again, they get simply converted into different hashes. So these are different hashes that are followed. So now we move ahead, and these digests, they get something known as CID. They get converted into CIDs. You know what CIDs are? Content identifier, and these are the basic foundations of IPFS addresses. So once we get various chunks converted into the respective CIDs, we get one single base CID. Now base CID is again enabled on all these multiple CIDs that we are seeing on the screen. So at the end of it, we get something known as base CID, and this is what runs the IPFS. So we move ahead, and okay, now you see on the screen there is some similarity among all the addresses. All the chunks are different, but all the hashes are different, but they have an initial like QM. Now why is this QM? So I'll explain this later, but for now what you can just remember is that there are two versions of naming, CID 0 and CID 1. So when we see an address which looks something like what you see on the screen, so V0, there is always a QM which is prefixed. So this QM will always be there. So whenever you see an address which is starting with QM, it means it is a CID version 0. That means the naming version is V0, and that starts with QM. Similarly, for version 1, we have got BAFY. So whenever you see on the screen, whenever you see, you do it yourself, if you see an address which is starting with BAFY, so that simply means CID version 1.
So a content identifier or CID is a label basically used to point to data in IPFS. It does not indicate where the content is stored, no locations, but it forms a kind of address in itself. Because it has been generated from the content, so it becomes a kind of address. The content is the address. So CIDs are short regardless of the size of their underlying content. That means basically, suppose we have got one small text file containing few words, and then we have got another a GB of Excel file or a database file. So both will have the same length of hash. So it is not dependent on the length of the data or size of the data. So CIDs are, as I said, they are based on content's cryptographic hash. So any difference in the content will produce a different CID, and the same content added to two different IPFS nodes using the same settings will produce the same CID. So that basically takes care of the deduplication that we'll understand a little later. So IPFS uses the SHA-256 hashing algorithm by default, but then there is a support for many other algorithms. The multi-hash project that we'll discuss a little ahead. This represents the work for this with the aim of future-proofing the applications, use of hashes and allowing multiple hashes to coexist.
So now we'll just go to this website and we'll just pick up a file to see how exactly the things are being done. So we'll close these and we'll go to dag.ipfs.io and we press enter. So this is one website that you see here, and we'll pick a file, and we'll pick a file. Okay, we'll pick this file, and it takes few seconds, and we'll be able to see some subsets of information. So what you see something here. So what we see is 1, 2, 3, 4, 5. There are 5 triangles that you are seeing. So we'll just zoom into one. So this is the thing. So okay, now before you zoom into one, so the central part. So this is the file. This is the main file. This is the file that I have taken, and this file has been divided into chunks. These are multiple chunks. Now just get into the thing, and this is the one chunk, and again this chunk has been divided into multiple chunks, and these all multiple chunks have their respective IPFS hashes. Now you see something below. What you see on the screen here. So if you keep your eyes here, you will be able to see that the IPFS hashes changing for every chunk. So here, and you see all these are multiple chunks, and it has happened in a matter of seconds. So here I have got various parameters. So fixed 512 byte chunks. So every chunk which is here, you will be able to see it is about 523 bytes total. So as I have identified, it is supposed to be 512. So now if let me change the parameters and let me change it to 1024. So what is going to happen? The chunks are going to reduce, the chunks are going to increase in size, thus the complete umbrella. Otherwise we had 5 triangles, now we have got just 1, 2, 3. And again, so if you see anything, so now if you see here 1035 bytes total, because I have taken this 1024 bytes, so we are seeing the difference. Again, you can also check out this website currently, which I'll be ultimately explaining later also. CID inspector. So this is cid.ipfs.io. Now I have got a CID v version 0 here that I have pasted out here in the example. I have simply pasted it here, and now this CID version 0, now this has been converted equivalent into CID version 1. So this is what you see, and you can just have a look. So although this I'll be taking on in a separate video, but for now that you should just be aware that the CID has got 2 versions, 0 and 1. So this, if this is 0, so because basically it is starting with QM, and the equivalent can be BAFY. Now there is a way that you will be able to convert from CID version 0 to version 1 that we'll discuss in some other video. For now you just take it that you can go to this website and do some experiments, and you can just play around with and these are basically the divisions of what is, there is a multiple base, there is a prefix, there is a name, base 58 BC, code implicit, etc. So there are things that we'll understand later. For now, version 0 to version 1, how do we convert? This is the way. So now we get back to the presentation. So content addressing looks. So how does a IPFS file looks like? So as we have already discussed that the CID version 0, which you will be predominantly seeing around whenever you start looking around IPFS on the web. So you will get lots of examples, and which will have inherent the CID version 0. So like here we have got QMX0, etc. So this is one IPFS address that we are seeing. So this is known as the content identifier, and this is known as the CID. So content identifier is a cryptographic hash of the content at that particular address. So address is IPFS/. Now there is no HTTPS here, you see. We'll get more clear on this. What are the other options? So hash is, of course, we have discussed in the earlier videos. I'll put a card also wherein I have discussed about the hashes. So hash is a unique to the content. So if there is a difference of file, even by a full stop or a comma, the complete address is going to change. So hash is unique to the content that it came from, even though it may look short compared to the original content, and also allows to verify that you got what you asked for. So like I had taken in the example earlier that there was a pic at 6 PM and there was a pic at 7 PM. The URL was same, but the content was different. Here, if the content changes, the complete address changes per force. Otherwise, you definitely go to the erstwhile address only. So you will not be able to change content easily. So address of a file in IPFS is created from the content itself. So your content is the address, and it links back, and the links in the IPFS cannot be changed because they are all enabled on hashes. And the most important, few important things are that if the text on a web page is changed, the new version gets a new different address, and content cannot be moved to a different address. if you are trying to assimilate the content hashes, how the hashes are basically enabling the IPFS system, this content cannot be moved to a different address simply as we keep doing in the traditional way. So imagine if a company could reorganize content on their website and move a page at so and so whatever we to another URL. In IPFS, the old link would still move at the earlier URL only. That is what we do because the content is the same. So in the case of IPFS, when we move to a different website, we plan to move to another URL, the complete thing remains different from a URL point of view because the content hash changes. And whenever we try to address or whenever we try to retrieve some data from a URL, so we'll have to have a different address to it. So content addressing. So while it looks very simple, when the image is added to the IPFS, like we had just added that particular file, it gets converted into raw data and then made content addressable, enabled on hashes for unique identification. So if we see directly, so what is happening is we input something like a photo, and directly what we were getting there on the DIG side was CID. We were directly getting the CID enabler, CID number, but there is lots happening behind that. I tried to show you that there was something known as converted into binary, and that binary being converted into chunks, and that chunks getting changed into digest. So that is all happening under the hood. That is all in the backend which is happening. So if we try and correlate, so input is this. We have got this input, we have got this binary, and we have got this chunk, and we have got this digest. But when we do it on a IPFS protocol with the help of a command, or we use a third party, what is directly happening is that we are simply entering this input, and we are simply directly getting this base CID. Sorry, I'm still to get used to with this my pen. So everything is happening majorly under the hood: binary, chunk, digest, CIDs, etc. as we had seen. So on the front end, whenever we work directly on the IPFS, we simply input a file and it gives a base CID without getting too much hassled about what for that. First we need to convert into binary, then into chunks, and then into digest, and then into CID, etc. So that all happens under the hood. So finally we have only two basically things: input and the base CID that we generally see in the IPFS protocol. So content addressing is hash functions take input at the rate of, it can be any kind, as I said, text, photos, videos, music, and they give us an output. That is a hash digest, which is a base CID, and which is unique, and because it is peculiar to the content, peculiar to the content of input. So it is basically tamper proof. So if there is a URL which is hacked, and suppose it is hacked, and suppose 1.png is changed, so in the traditional manner, when we access that website, the new content will be seen at the same URL. But in case of IPFS, because the content is changed and the content is enabled on IPFS hashes, which are again peculiar to the content, therefore whenever a URL is changed, whenever a content is changed, the complete thing, the IPFS makes sure that you will not be able to move the content. I hope you're getting it. So from a URL anupam.com/1.png, the traditional way, anupam.com.1.png. So in the traditional manner, the website remains the same, but the content is different. But in IPFS, the moment the content is changed, the address changes. So that's one strong thing that comes out of IPFS. So one cannot tell what was the input, and this is another thing, that whenever you have a IPFS address, you will not be able to guess what is the content like. Like on a website, you will be having like anupam.com/1.mp3 or 1.pptx or 1.docx or anything, 1.text. So you'll be able to know that this website refers to a music file, a video file, or text file. But in case of IPFS, because the IPFS basically it will be referring only to the IPFS hash, so you will not be able to guess anything on the content part. So this ensures a great amount of security. So content addressing, how do we achieve? What do we achieve? How do we achieve? Of course, I'll take it on while we do it practically in the next video. So what do we achieve is liberation from the reliance on central authorities. So if Wikipedia page, that the first example that I had taken, if the Wikipedia one day decides that this complete thing is banned and this will not be accessible in a particular area, or we ban it globally, but on IPFS, the name itself shows that InterPlanetary File System. It is interplanetary, not even intra-global. will be accessed at the global level, but even at a planetary file system, that what their intention is that there will be absolutely no stopping of uploading a content and sharing a content. So key features I'll just quickly revise. IPFS is content addressable and data is identified using CIDs, that is the content identifiers, which are enabled on hashes. These CIDs are unique because every content is unique and every hash of the content will be unique with respect to the data referenced. They use hash functions for its tamper-proof property, which makes it self-certifying file system. They use multi-hashes, so which allows it to have different versions of CIDs for the same data, that is future-proof. Now,
so let's understand this multi-hash concept in much brief. So this cryptographic hash functions often have multiple output sizes and encodings. For example, like SHA-256 will have a separate length of output, MD5 will have a separate length of output, and otherwise MD5 etc. all RIPMD 160 kind of hashes, they will all have different kind of length outputs. So this variability makes it difficult for the applications to determine which hash function has been used on them. So multi-hash, the concept is a universal data format for encoding outputs from hash functions. And it is useful to write applications that can simultaneously support different hash functions instead of just one hash function, as well as they also support upgrade of hashes over time. So multi-hash is intended to address these needs, kind of upgradation, easy upgradation and more security, and in even handling situations like even if the hash is broken. So a multi-hash describes the algorithm used for the hash as well as the hash value. So multi-hash is a protocol for differentiating outputs from various well-established hash functions and addresses the size as well as the encoding considerations. So it is useful to write the applications that future-proof their use of hashes and allow multiple hash functions to coexist. So these are particularly important in systems which depend on cryptographically secure hash functions. So predominantly when we see blockchain, IPFS, they are all moving around hashes and they form the core cardinal backbone in their basic mechanics. So suppose we can envisage a scenario of attacks in future that may break basic cryptographic properties of a particular secure hash function. And obviously, if such kind of a break happens, this will be particularly painful during any kind of upgrades, wherein if the applications using these broken hash functions, they have some predetermined assumptions like preset hash length or function or digest sizes. So this kind of upgrade suddenly becomes a nightmare, finding that kind of a hash function which has got the same format, same length, and the applications may face serious interoperability problems or maybe error-prone casing. And this is precisely where multi-hash function shines, and it was designed for upgrading and making the cryptographic hash functions any kind of upgrade, safer and easier.
So, and again, it gives out another feature which is deduplication. So there is one file that I upload on the web. So what I upload, suppose I have a unique file 1.pptx. Now this is some presentation which I share with my friend. So I share this particular presentation with my friend in the traditional manner. So what happens is that on the traditional web, I will have a copy on my email, he will have a copy on his email, and we will be duplicating it basically. So I have my copy and he has his copy, but both are the same. But in case of IPFS, what happens is it removes this problem of deduplication, the duplication part. Why? So because it has this feature that whenever a content is there, so it has a unique hash. Now whenever there is a unique hash, so it is only representing one particular file. So when there are chunks of file of the same file, as you see on the screen, we have got chunk 1, chunk 2 and chunk 3. So here we have got this and this. So, and we have got these sub chunks 1, 2, 3. So suppose, this is just for an example for understanding purpose. Suppose there are two files 2, 3, 4, 5, 6, and we have got another 2, 3, 4, 5, 6, and then we have got about 3, 4, 5, 6, 7, and again 3, 4, 5, 6, 7. So there is a repeat. So in the case of IPFS, what happens is that the copy does not get duplicated. It is simply negated because a similar hash is existing somewhere on the P2P network, on the IPFS network, somewhere the same hash is existing, so it will not duplicate itself. So here we'll see this in a practical demonstration also in the next video or maybe in some other video. The thing is the duplication part, which is again a very big problem, that there are multiple isolation of islands with the same data across multiple computers, millions of computers, same data, same file, it is being downloaded. But in case of IPFS, we have got one central hash. So all the chunks, all the file chunks which we are trying to access will be distributed across the globe, and whenever some user asks that I want this file, so they will simply call that particular hash, and then they will be able to assemble that particular chunks, and then they get the final file. So how do we access the IPFS files? So this we'll discuss in the next part, because theoretically I'll not be able to justify the thing, but I'll try to explain this. First of all is, if you want to upload IPFS files, or if you want to access IPFS files in case you have a hash, so there are few ways that either you install the IPFS protocol software in your PC, which is again different for different operating systems. Like for Linux, for Windows, for Mac, there are different versions of IPFS which you can suitably download and install in respective operating system. Then there are few browsers like Brave or Opera, wherein this IPFS is coming inbuilt, so there is no need to download anything. You can simply use that browser for accessing the files. Then there are gateways, access through gateways. Now gateways are basically an intermediate option, wherein you see, if you see this example that I have given is HTTPS. Now HTTPS is not supposed to be there, even in the second address that I am giving out, the Cloudflare, here HTTPS is not supposed to be there, but this is a gateway. Now gateway means that in case you do not have IPFS browser, in case you do not have a IPFS software installed, then there is a third party, which is Cloudflare in the example shown, or IPFS.io, which through a traditional gateway is giving you an option that you can access that file through this HTTPS gateway. So this again we'll see it on a practical form, and just check out this IPFS.github.io, the link that I have given here, which I'll be also mentioning in the description. Just try accessing these links that I have mentioned here, and you'll be able to appreciate much better content. So before, okay, so till now what I have spoken about IPFS, it looks pretty simple, that you have a file, you upload it to IPFS, it gets divided into chunks, those chunks get converted into respective digest hashes, those digest hashes convert into respective CIDs, and all those CIDs combine together to form a simple base CID. But as I explain here, or as I have explained you theoretically, or even give you an example on a simulated browser, that dag.ipfs.io, the things are not exactly as simple. There is lots behind, and these are like content linking via DAGs, Merkle DAGs, libp2p, all these technologies what you see on the screen currently, content discovery via distributed hash tables, interplanetary name system, very important, IPLD, interplanetary link data, multi-hashes, CID version 0 and version 1, which I have mentioned a little bit. But all these technologies, these are independent, complete things that require much effort in explaining, which I'll try to take on in some other videos. But all these technologies do a lot of things behind the scene, and these are all responsible for making it look so simple. So these are all the foundation technologies that work behind in an IPFS. So there are a number of technologies that go behind. These technologies are complete ecosystem in themselves. Like suppose I take IPNS, interplanetary name system. Now when you start reading about IPNS, it is a complete ecosystem in this sense, because again it is a number of technologies which are working behind IPNS alone. In case we take about interplanetary link data, again there are a completed separate mechanics which is making this happen. So there are a lot of technologies which are basically I'll say the foundation technologies behind the complete thing which is known as IPFS. So till now I'll just revise upon, we have a file, and we upload it to IPFS. That file gets converted into chunks. Those chunks get converted into respective digests. Those digests get converted into respective CIDs, and then all those CIDs combine together to form a base CID. And what are we achieving with IPFS? Distributed storage. So with this, I'll like to end this video, and we'll continue in the second video, in which you will see the practical part, the simulation part, how do we install it, how do we use it on a command line interface, and how do we basically upload it, and how do we retrieve it at another end, and what are the addresses like, what is CID version 0, how do we convert from CID version 0 to version 1 on a IPFS CLI terminal, how do we install it basically, etc. And all this complete thing I'll just touch upon. So as I mentioned, this is just a brief glimpse and an approximate introduction of IPFS. So might have found it confusing, because once at the onset when you do it yourself, it looks pretty easy. You will be able to install it easily, you will be able to upload your files easily, you will be able to retrieve files easily. But when you go behind the scenes, is basically a little complex, and this complex is only till such time you are not aware of what is happening and how is it happening, and which we'll try to make it amply clear in the complete IPFS playlist that I intend to populate over next few weeks and months. So thank you very much for watching till here, and if you have liked it, do subscribe Blockchain Nuts and Bolts. Thank you very much. Bye.